Hello, class 10th physics, chapter magnetism, topic electromagnetic induction. So, here we have three situations. First, magnet is moved toward the solenoid, magnet moved away from the solenoid, and magnet is kept stationary. I have marked north pole. Same thing can be happen with south pole. So, in the exam, they can ask what will you observe. The same question can be asked in another way that show an activity or um, uh, state an activity to show electromagnetic induction. So uh, instead of giving you direct answer, I am showing you a demonstration. So I have this galvanometer and see it is not connected to any other source, and I have this solenoid. So it is made up of copper wire, insulated copper wire. Actually, it is not simply a copper wire but insulated one. There's a thin layer coating, oxide coating over it. That is why it is looking um brownish yellow, and there are two terminals. It is closely wound over iron core. Now I have these crocodile clips or alligator clip, whatever you can say. So I am connecting it with this galvanometer. Alright, so here it is. Now I have a magnet. Well, so actually I'm clueless that which end of it is north pole. So let me tell you clear that in this problem the main idea is a magnet is being moved toward the solenoid. So also let us suppose this is north pole. I can find it out, but still I can instead mark any of it north or south, so that doesn't make a sense. So here I am moving it toward the solenoid. You can see a deflection, and then it returned back. Why it returned back, I will explain it later, but the bigger idea is this, a deflection. So when I am bringing it close, it is deflecting. When I am moving it away, it is deflecting on other side. You can see. So in first case, you can say that it will show some deflection. Let us suppose this way. In any direction you can show that, and when it is moved away, opposite to this. Instead, if you draw in first case, if you draw this way, then you have to draw in opposite way in next case. This is the only key. Now the thing is, third one, if it is kept stationary. So let's try it. Okay, now I am keeping it stationary. Nothing is happening there. So this is what happens in electromagnetic induction. So whenever magnetic field linked with this coil changes, actually when I am bringing it close, then magnetic field through this coil increases. So when magnetic field linked with this coil changes, then only induced current flows through the coil, which we can detect in this galvanometer. You can see. But if I'm not, I'm just placing it stationary in front of this coil or solenoid, it is not showing any deflection. Now another thing, if I move it slowly, then deflection is less, and if I bring it fast, then deflection is more. Instead, if I move this coil, this solenoid toward the magnet, still deflection is large. Now there is another question in which there are two solenoids coupled with each other, most of the time sharing same core, but what I am going to demonstrate is not on same core, but they are close to each other, so result will be the same, there will be no difference. So just on, just off, two condition we will discuss. What is going to happen? Just on, okay, we expect that there will be some deflection here, although it is not connected. What I am going to say, I am going to demonstrate that. So ये बैटरी एलिमिनेटर है, ये एक कॉइल है, ये दूसरी कॉइल है with connected with some galvanometer और electromagnetic induction हो रहा है. Well, I'm not making trying to make a joke, but all right, because ये है तो है. You can see there are so many wires and all that. This is a battery eliminator. Actually, it's more like an adapter, and I have set it not a higher voltage, just 2 volt, and it is connected to this solenoid, same as this one, and other solenoid which is connected to galvanometer. So here is that, and both are not connected. I'm keeping it close to this. They are not connected, no wire connection is there, but still what we will observe, we'll see here. All right, so okay, I have placed it close to it, and there's no wire connection with this circuit. This will contain the current, and it will create some magnetic field. That magnetic field will pass through this coil, and when I switch on, magnetic field will increase in it. That is why it is increased in the second solenoid, and there is some deflection because of electromagnetic induction. Even when we switched it off, still as magnetic field is changing, still there will be some induced current. So let's see. You can see when I just switched on, deflection is this way, just switched off, deflection is that way. But if I am keeping it on, then there is no deflection. So if now what is happening, actually there is constant magnetic field in this solenoid, so constant magnetic field is passing through this solenoid also, and if there is no change in magnetic field, there is changes, then there is induced current.